Public key encryption allows for encrypted private messages. A message sent from Bob to Alice gets encrypted using Alice's public key. Public key encryption also allows for signed messages, so that when Alice signs a message, Alice uses her private key and Bob can verify it if Bob has her public key. In both cases, in both the case of sending an encrypted private message and signing a message, Bob needs Alice's public key. If Bob gets that public key from an email message, Bob is trusting that the email message is secure. And if Bob can't ever verify that very first message that contains the public key, he has no way to verify the messages that come after it. This is the problem of key distribution. How do I get your public key securely? Key distribution undermines the usability of PGP encryption. Serious encryption advocates will sometimes meet in person to exchange pieces of paper containing public keys. Keybase is a company that attempts to solve the problem of key distribution by having users connect social media accounts and devices to Keybase in order to collectively verify who you are and then give you the power to share your public key reliably. Max Krohn is a founder of Keybase, and he was previously a founder of SparkNotes and OkCupid. He was on the show a few years ago to discuss the basics of Keybase, and in this episode he explores some of the abstractions that Keybase has built on top of its core identity tool. That includes Keybase File System, Keybase Teams, and Keybase Git. We do break down the basics of Keybase, but if you want a more thorough explanation, you might like to check out that older episode, and you can find the first episode I did with Max on the Software Engineering Daily app, which is on iOS and Android, and you can find all of our old episodes in addition to that episode with Max. With that said, I hope you enjoy this episode with Max Krohn. DigitalOcean Spaces gives you simple object storage with a beautiful user interface. You need an easy way to host objects like images and videos. Your users need to upload objects like PDFs and music files. DigitalOcean built Spaces because every application uses object storage. Spaces simplifies object storage with automatic scalability, reliability, and low cost. But the user interface takes it over the top. I've built a lot of web applications, and I always use some kind of object storage. The other object storage dashboards that I've used are confusing. They're painful, and they feel like they were built 10 years ago. DigitalOcean Spaces is modern object storage with a modern UI that you will love to use. It's like the UI for Dropbox, but with the pricing of a raw object storage. I almost want to use it like a consumer product. To try DigitalOcean Spaces, go to do.co/sedaily and get 2 months of Spaces plus a $10 credit to use on any other DigitalOcean products. You get this credit even if you have been with DigitalOcean for a while. You can spend it on Spaces or you can spend it on anything else in DigitalOcean, and it's a nice added bonus just for trying out Spaces. The pricing is simple. $5 per month, which includes 250 gigabytes of storage and 1 terabyte of outbound bandwidth. There are no costs per request, and additional storage is priced at the lowest rate available, just a cent per gigabyte transferred and 2 cents per gigabyte stored. There won't be any surprises on your bill. DigitalOcean simplifies the cloud. They look for every opportunity to remove friction from a developer's experience. I'm already using DigitalOcean Spaces to host music and video files for a product that I'm building, and I love it. I think you will too. Check it out at do.co/sedaily and get that free $10 credit in addition to 2 months of Spaces for free. That's do.co/sedaily. Max Krohn is the co-founder of Keybase. Max, welcome back to Software Engineering Daily.
Thanks, Jeff. Great to be here.
We had an episode a couple years ago where we discussed the foundational concepts of Keybase, but let's reintroduce people who may not have heard that episode. How do you describe Keybase as a company today?
Sure thing. So we are a company that is trying to make it easy for people to use public key technology in their lives. And so what that means maybe three different things. The first is that we make it easy for people to publicize their cryptographic identity, which means that we make it easy for people to have a public profile that shows how you might know them through social media and also what their public credentials are so you could communicate with them securely, or if you want, so you can verify things that they've authored. And those, those two things are like the yin and the yang of public key crypto. It's both useful for encryption and also for signing and verification. But to get back to people's public profiles, if you look at my public profile on Keybase, you'll see that I have verified ownership of several social media accounts, like a Twitter account, a GitHub account, a Reddit account, etc., and also that I'm the DNS administrator of several DNS domains. And what that means is I've actually signed statements in my Keybase profile saying that I own control of these resources, and then if other people who want to check that out can see that I've actually posted those on the resources that I've claimed to own. So therefore, anyone who would be trying to impersonate me would have to go through all those steps, which might be very hard because they'd have to break into all of my different social media accounts and post bogus things on them. So that's the first thing that Keybase really is for people. It's a way for them to publicize who they are and the cryptographic keys that correspond to their identity. And so that's where we really started, but we realized quite quickly that in order to give people that set of features, we had to provide them a convenient way to manage their private keys. So for every public key you have, there's obviously a corresponding private key that only you should hold and no one else should have access to. But traditionally, it's been very hard for people to manage private keys. If you ask PGP how to do it, they'll tell you it should be on a USB thumb drive that you keep in a safe somewhere. And you're probably on your own if you want to move it onto your smartphone, because obviously you shouldn't be moving the secret key in a way where any sort of bad guy might have access to it. And that's very hard with smartphones. So what Keybase also provides is a way for users who don't have to have the most technical know-how in the world to manage their private keys. And the way we do that is that every device you install Keybase on gets its own private key. And if you want to add a new device, that means you have to introduce it to one of your old devices, and they share authorization with each other. So now your new device has a new private key that is unknown to any of the other private keys, and also any of the other devices, and also unknown to Keybase. It's unknown to anyone but the owner of that device. So we've tried to make that very easy for people because it's a tricky thing to get right. And we also want to give people a way to recover their identity and not get totally broken into if they manage to lose one of their devices, which actually, as you can guess, happens a lot. If your hard drive crashes, if you leave your phone in a cab, that should not be the end of your cryptographic identity. You should not have to reset. Rather, you should be able to say with one of your other devices that, oh, hey, I lost my phone in the cab, so just don't use that device anymore. Just use the other three devices that I still have access to. And then you can go on and not have to reset everything about you publicly, which is also a pretty key innovation over things that used to exist. So those are the two things that Keybase is really trying to do at a technical level to make it easier for people to use public key. And maybe one level up from that is we want to give people applications that they could use on top of this public key technology that are actually useful in their lives. So people find it very useful to send chat messages, to share files, and recently to share Git repositories. And we want to make it very simple for people to use the public key infrastructure of Keybase along with these applications that they're currently using today, just in a less secure format.
Public key encryption is widely used when all of my web traffic and my chat messages, they go through HTTPS already on the internet.
Yes.
So what use cases are you solving for?
That's a great point. So it's true that if you're a bank or if you're an internet service or maybe if you're kind of a technically sophisticated website hoster, that you can go and get a public key and a corresponding private key for your website. And that means that anyone who's at Starbucks who wants to contact your website or contact a bank, they'll know that Starbucks can't see the messages in between. And that's obviously great for a lot of people's usages. And clearly, now that we know that WPA2 is pretty broken, that just came out today, it's good that people are using this technology. However, what that means is that whenever you communicate with your bank, let's just use that example, fine, Starbucks can't see what you're talking about, but the bank sees everything you're talking about as you want it to. So maybe a better example is like, let's say you're communicating with Dropbox. So you're syncing files to and from Dropbox's servers at Starbucks, and Starbucks can't see your files. But Dropbox can see your files, and so Dropbox is able to index them and back them up and do whatever sort of internal data analysis they want to do on your files. And that might not be a good idea for a lot of different people. One thing you might be afraid of in that case is that there's someone evil within the organization who's snooping on people's documents and wants to figure out maybe the cap table of your company if you decide to store them in Dropbox. Or even if you give these companies the benefit of the doubt, which, personally speaking, I do, it still is a question that they might get hacked at some point. And when they get hacked, what that'll mean is anything on their databases will become open for anyone to download, and all of your secret documents will become public. And we've seen it happen with a number of different large-scale providers like Equifax and Yahoo. And some of these other providers have better track records, but they're just one mistake away from kind of letting the cat out of the bag, or the horse out of the barn, as it were. And if you are in a relationship with these providers where you can lose your password and they can just reset your account, then you know that everything they have is somehow available to them in plain text. And that's true of almost everything people use on the internet today. So in 2017, where security seems to be getting worse all the time, it seems like people might want to take matters into their own hands. And the only thing you could do as a user who's slightly distrustful of your service provider like Dropbox or Google Drive is to make sure that they only get to see encrypted data. And that way, if their data is ever hacked, all the hackers and everyone else gets to see is the encrypted version of your data and not the data itself. Mm-hmm. So that's what people having public keys allows. That goes a couple steps further than just the websites having public keys.
Mm-hmm. Okay, makes sense. Public key encryption allows for these encrypted private messages or encrypted files. I can encrypt individual files within my Dropbox folder. So when I sync my local Dropbox with the remote Dropbox, it's going to sync encrypted versions of those files. And
yes,
those messages, those files are getting encrypted using my public key. And also this public key infrastructure allows for signed messages, so that if you sign a message, you are using your private key, and I can verify that it came from you if I have your public key. So in both of these use cases, I need your public key. In order to make these things work, you have to have a way of sharing public keys with people. And if I get that public key from Twitter, or if I get it from an email account, I can't ever verify that first message, which contains the key. So this is the key distribution problem.
Yes.
And this is why people historically have had these key sharing parties where you show up in person and you give your public keys to people. How does Keybase approach the key distribution problem?
Yeah, that's a great question. And I feel like we've seen a really exciting proliferation of security apps like your Telegrams and your Signals. And those apps are super exciting, but they've all cut this corner. And they've basically just said, we have these great protocols to make sure that people, once the key is exchanged properly, can enjoy privacy. But as far as the key exchange, they're just saying, trust us, we'll get this right. And there's no way to audit that. And so Keybase kind of started with the other way of thinking about it. We thought we wanted to solve the key distribution problem first and then build apps on top of it. So if Jeff, I wanted to look up your key on Keybase, what I would do is I would first find one of your known social media handles to look you up. So I could look you up by anything you've chosen to prove. And then once I've done so, my client who's running Keybase would do a couple things. It would first pull down the record from the Keybase's infrastructure about what the most up-to-date version of your profile is. And that's a little bit tricky to get right, but what that is it's a sequence of signed statements saying, you'll start that statement with, hi, I am Jeff, and this is my first device, and then you might say, I'm adding a second device, and then you might say, revoking my first device and adding a third device. So those are types of statements that you might see. And also, I'm claiming ownership of this Twitter account. and I'm claiming ownership of this GitHub account, etc. So when I go to look up you, I pull all the information about your account. It's this chain of signatures. I play them back and make sure that each one is successfully pointing to the previous one and that everything's signed by a device that should have been signing for you at the time. Then after that's all done, I look at all these external proofs that you posted, and I make sure that they still exist in the places where you posted them. And so what that means is that my client is actually going to make a HTTPS call to Twitter or to GitHub to make sure that the data that you said was there is actually there. And once I put all that together, what I wind up with is a set of public keys that identify you, one for each of your devices, and also a knowledge that these other social media accounts that you say are yours are actually owned by you, and you consented to associating them with your profile on Keybase. And this is a lot of steps to get right, but it's where we started, and it's this notion of identity that we build everything else on top of.
At Software Engineering Daily, we need to keep our metrics reliable. If a botnet started listening to all of our episodes and we had nothing to stop it, our statistics would be corrupted. We would have no way to know whether a listen came from a bot or a real user. And that's why we use Encapsula, to stop attackers and improve performance. When a listener makes a request to play an episode of Software Engineering Daily, Encapsula checks that request before it reaches our servers, and it filters the bot traffic, preventing it from ever reaching us. Botnets and DDoS attacks are not just a threat to podcasts. They can impact your application too. Encapsula can protect API servers and microservices from responding to unwanted requests. To try Encapsula for yourself, go to encapsula.com/2017podcasts and get a free enterprise trial of Encapsula. Encapsula's API gives you control over the security and performance of your application, and that's true whether you have a complex microservices architecture or a WordPress site, like Software Engineering Daily. Encapsula has a global network of over 30 data centers that optimize routing and cache your content. The same network of data centers are filtering your content for attackers, and they're operating as a CDN, and they're speeding up your application. They're doing all of this for you, and you can try it today for free by going to encapsula.com/2017podcasts, and you can get that free enterprise trial of Encapsula. That's encapsula.com/2017podcasts to check it out. Thanks again, Encapsula. If I understand correctly, this is a decentralized trust model where you have your initial key sharing that is backed up by the ensemble of your Twitter and Facebook and GitHub and whatever other social accounts. And the bigger an ensemble you have, the more reliable your initial public key sharing is. Is that correct?
Yeah, I think that's correct. I think you want to have more devices because you want to be robust to the loss of any one device. And, unlike other services, when you lose your last device, your data is gone. Like there's nothing anyone in our company can do to recover that data for you. So you really want to avoid that situation. And so that's why we encourage people to add many devices to eliminate the chance that they'll lose all of them. And we obviously further encourage people to use endpoint encryption, for instance, on your iPhone, or full disk encryption on your Mac to make sure that even if someone does lose that device, if you lose your device and someone captures it, that they can't actually access the public key, the private key in that device because it's encrypted. So that's why we ask people to use to add multiple devices. And it is decentralized, as you say, in the sense that we don't want our users to have to trust Keybase. We want our users to understand how the software works and for them to be okay with the software expressing the ideas that I'm expressing to you right now. But if our servers start to lie to people, for instance, if we become hacked, or if some foreign government agency tells us that we need to lie about certain public dissidents or whatever, we will not be able to, because the software that's already in the wild is holding us to the earlier contract that we made. So in that sense, the trust is decentralized, because if you're a bad guy and you want to take over someone's Keybase account, you'd have to both hack their Keybase account and also all their other social media accounts. So in that sense, it's decentralized. I get in trouble with like the real hardcore decentralization people, like the Bitcoin or Ethereum people, if I say Keybase is decentralized, because we are not running our infrastructure on a blockchain. We run our infrastructure, as a traditional web service, and every 12 hours we post the most up-to-date version of our Keybase database to the blockchain. So we use the blockchain to make sure that we haven't been coerced to show two different versions of what Keybase's database looks like to different people. But the infrastructure is really hosted on traditional kind of cloud-based hosting services. And a lot of people would potentially argue with us about this decision, and I'm happy to defend it, but I can't go on the record and say, this is a fully decentralized application.
Mm-hmm. Once I have initialized my identity being synced with Keybase or my multiple devices and my social media accounts, all with my Keybase account, I can start to do some interesting things. And the first interesting thing that you built was the Keybase file system. Explain what the Keybase file system does.
Sure. So we thought about how if people did care about end-to-end security where Dropbox or Google Drive can't know what's in your files, we thought about what the steps involved would be. So the first thing you would have to do is look up someone else's public key. You'd have to encrypt a file for them using their public key. You'd have to put it into Dropbox. They would have to download it from Dropbox, then decrypt it with their secret key, and then open the file. So what KBFS is, it's combining all steps of that chain into a simple operation so that the users are basically ignorant to the fact that the cryptography is actually happening, is just magically happening under the covers. And so when we first started KBFS, it was more like one-on-one sharing opportunities. So if you knew someone else, maybe a couple of people you wanted to share with, you could make a folder that the three of you could access, and then anything you put into that folder was signed by you and encrypted for the other two people in the share to see, and they would have the reciprocal experience when they went to read the file out of that share. We've recently improved that feature by adding the notion, very obviously natural notion, of a team. And a team, as far as Keybase is concerned, is a group of, let's say, 1 to 100, 1,000 people that all go under that all can be captured under one name. Like, let's say, Poker Pals is one we use. It's like an informal team, or maybe a more formal one is like Keybase_corporation or whatever. And so that's interesting now because they could be a lot bigger. You don't have to list the people who, with every file access as you did with our previous use case. And also that membership can change. But once you have a team of people, the same KBFS operations still work. You put something into the folder, and it's now encrypted, signed by you and encrypted for everyone in the team. And then they get to read out if they're in the team and then verify that you wrote it. So that's basic KBFS, both in the original case that we put out there and also the more recent iteration that has the team support for it. But it shows up on your Mac or Linux or Windows machine as a regular folder, but it's a folder with seemingly magic properties because it's doing all this crypto under the hood without your applications or you really having to know about it.
So a simple example is if I want to post a soup recipe to a folder and I want to share it with 3 of my friends, why don't you walk us through, just refresh for the people who were confused on the first explanation of creating a Keybase account. So let's say these 3 different people, they create their Keybase accounts, they create a shared folder. Give us an overview, kind of an abbreviated, condensed version, because I know you already explained the process, but I think just to refresh people, give them a second chance to catch up for what they might be confused about.
Okay, great. So let's say I'm Max and I'm sharing with 2 people. Let's call them Alice and Bob. So software running on my computer, when I first go to share a file, so I'm just, as you said, I'm just dropping a soup recipe into a folder. What my software will do is it'll look up Alice and Bob on Keybase. It will, as I mentioned earlier, it will play back their identities. So Alice has 2 devices, Bob has 3 devices. They have both these set of social proofs. And my client will, if Alice and Bob are people I've never spoken to before, it will show me what their profiles look like. If they are people who I've spoken to before, it will just check to make sure that everything is still as it remembers. And if so, it will take these, Alice had 2 public keys, Bob had 3 public keys. Let's say I have, 4 public keys. So in total, that's 9 public keys. My client will then cook up a shared secret. So let's say it'll be a 32-byte secret, and it'll encrypt it for each of those 9 public keys. And then it'll use that shared secret to encrypt the file, the soup recipe that we put in the folder. So basically, we're not encrypting the soup recipe 9 times. We're encrypting it once, and we're giving the encryption key to everyone who should have access to that folder via public key technology. And the other thing my client will do before writing that soup recipe to the folder is it'll also sign it with the private key of the device that's doing the sharing. And then once that's there, Alice and Bob can go onto their devices. They'd first basically do this whole thing in reverse. So let's just say Bob finds the encryption of the secret key for his device. His device will decrypt it. That will yield the 32-byte shared secret key, and then that will be used to decrypt the soup recipe. So that's just one file, and we have the same guarantees over a whole hierarchy of files, and so file names are encrypted, the contents of directories are encrypted and signed, and you kind of add all these components up, and now you have this fully encrypted file system tree that Alice, Bob, and I are sharing. And as far as the Keybase servers are concerned, we don't even know what is the soup recipe and what is the directory that contains the soup recipe. It's just all blocks that are totally encrypted and hidden from us.
Mm-hmm. That's great. And now that you've simplified that example a little bit more, I think we probably have motivated things for people who may have been a little bit lost at the beginning of the show. This happens in some of the more complex topics where people are listening and like in the early stages of the show, they're just like a little confused, and then later on they're like, oh, I wish I would have understood that complex topic that people were discussing at the beginning. So for those types of people, let's quickly run through just one more time how somebody, like what happens during the sign up of Keybase, why this is an extra usability, modernized for our modern, multi-social network, multi-device world version of PGP.
Right. So the things that are different here in Keybase is that in an example I just mentioned is that I have multiple devices and not one device, and so does Alice, and so does Bob. And when I'm encrypting if I understand the question properly, when I'm encrypting for Alice, when I'm encrypting for Bob, and they're encrypting for me, I have to make sure I'm encrypting to the right, set of devices that represents them. And that set of devices is always a changing set of devices on the, just because over time we throw away computers, we buy new ones, etc. And so your identity is just cryptographically, it's a set of personal devices that represent you and a set of public-facing social media names that you want to be made known. And the challenge here that Keybase is trying to solve without anyone knowing about the details is just making sure that when I go to encrypt for Bob, I'm getting the 3 devices that he's currently using, not the one he left in a cab last year, and that this Bob has these 3 devices, and that he has proven to me that he's the right Bob, not a Bob who Keybase is claiming he is, but the right Bob because my client is also checking that he owns the GitHub account and the Twitter account and the Reddit account that I know him by. Mm-hmm. So these are all part of the same computation that if any of these components are done improperly, it would be an attack vector. And the attack vector might be that an evil Keybase, if our software didn't work properly, would insert a bogus device for Bob, and that bogus device would be one that a government agency controlled, and therefore the soup recipe would be known to the government agency because that 4th device that I encrypted for Bob mistakenly was actually not his device at all, but a bad guy's device. And so our client protocol is making sure that type of thing doesn't happen.
Mm-hmm. And when I am signing up for Keybase, there's this like event, right, where on all of these different accounts, on your GitHub account, on your Twitter account, on your Facebook account, you simultaneously publish what your public key is, right? Like there's a moment where all these things are synchronized. So when Keybase scrapes all these different sites and communicates with different devices, it can synchronize with all those at once and know that this is the ensemble of identities.
Yeah. So the thing we ask you to post to, so let's just go over, let's say the GitHub example. So when you sign up for Keybase and you prove ownership of a GitHub account, we give you this little block of text that you then go and post on GitHub. And what that text is, it's not just your public key. And it wouldn't really make sense for it just to be your public key, because then we'd be asking, well, which public key was it? Is it the public key that you then lost? Or is it like, what we do instead is we ask you to publish the last signature you've ever made in your Keybase account. So that basically captures the whole state of your account up until that time. So what we ask you to post on GitHub will be, it'll point back to your Twitter proof if you did that previously. It'll point back to the first device you ever used on Keybase, and maybe revocations of devices you lost in cabs, and provisionings of new devices you went out and bought because you really wanted to get the iPhone 8. So the thing that we ask you to publish on GitHub is a cryptographic summary of all of that stuff. And so it's way more powerful than just posting your public key. And so when I go to look you up, I make sure that whatever you posted on GitHub is the same thing that Keybase is reporting back to me. So therefore, I know yet in a different way that Keybase isn't lying and making malicious stories up to compromise your identity.
Mm-hmm. Okay. That makes sense to me. And for people who are still confused, I think you can go back to the previous episode that we did, or you can look on the Keybase documentation, which is really good, has some great explanations of what's going on here. Let's get back to the file system. How are these files stored and synced? Give me the client-server model.
Sure thing. So the easiest way to describe it is that there's basically, so this is not a Dropbox model where basically, so the Dropbox model more or less is whatever you put on your machine, Dropbox lazily synchronizes to its servers. And so after about a 10-minute, however much data you have after that window, all the data is synced in probably arbitrary order between your computer and Dropbox. So our file system has a bunch of different properties. I think the first property, which is pretty compelling, is that you can have 10 terabytes of files on Keybase, and only 10 gigabytes of storage on your device. And so that's actually quite useful for people who have more and more. It seems like our SSDs are not growing. They're not keeping up pace with the amount of data we have. So this is one thing that's very nice about Keybase, where you don't have to have as much local storage as you do files. But the way the Keybase system works is that our file system client is actually at the operating system level. It's understanding every system call that your application is making. So the first system call your application might make, let's say a word processor, would be to open up a file, and so that means the Keybase client running on your machine gets this open call and then sends that off to the server. The open, let me get this right, it's a little bit tricky, probably means that the directory that the file was in is modified. So then the Keybase client sends that new updated directory, encrypts it to the server as this encrypted block, and now that the directory with that new empty file in it is now on the server, so that other people who want to see it can download that new version of the directory and see that file exists. So that's the first system call. The next system call might be like a write. So let's say your word processor, you type a bunch of words, you hit save. That probably means there's going to be a write to the file and probably like a sync of that file. So what that means is a new file has now come into life. That's going to be encrypted. It's going to be a block, probably one, if it's a small file, it's going to be one encrypted block. That's then sent to the Keybase servers. The directory probably has to be updated because the file in that directory is a different file, so that probably the directory itself has to be encrypted and sent back to Keybase, and then so on and so forth, all the way up to the root of the directory tree. And so basically all that happens kind of piecemeal until eventually this file is put down onto storage, and the Keybase servers have it, and other users can now view the file. It's called a Merkle tree, basically, and the file system itself is represented as a Merkle tree, which is quite useful for performing cryptographic operations over the whole tree. So when you actually sign the state of the file system, you're not signing each individual file, you're signing the state of the whole tree, so that if someone wanted to tamper with your files and, let's say, change a file name or change what file a file name pointed to, that would be detected as a result of signing just the root of the tree.
When you talk about that Merkle tree that defines the file system, are you talking about a user's file system, or is this a global Keybase file system?
This is the global Keybase file system.
Okay.
And users are able to write into certain subtrees of it. And so, that soup recipe directory I had with Alice and Bob, that's a subtree of that file system. And above that, all those subtrees for each group of users is combined to get one global Keybase file system, which is also, the whole thing is basically captured in one 32-byte hash. That's like the state of the whole Keybase global file system. Of course, access control is very important here. So just because it's a global file system doesn't mean everyone can access all parts of it. And so the crypto ensures that you get to see only the right parts of this global file system.
You are programming a new service for your users, or you are hacking on a side project. Whatever you're building, you need to send email. And for sending email, developers use SendGrid. SendGrid is the API for email, trusted by developers. Send transactional emails through the SendGrid API. Build marketing campaigns with a beautiful interface for crafting the perfect email. SendGrid is trusted by Uber, Airbnb, and Spotify, but anyone can start for free and send 40,000 emails in their first month. After the first month, you can send 100 emails per day for free. Just go to sendgrid.com/sedaily to get started. Your email is important. Make sure it gets delivered properly with SendGrid, a leading email platform. Get started with 40,000 emails your first month at sendgrid.com/sedaily. That's sendgrid.com/sedaily. And what are those parts? So, if I'm Jeff and I've got a shared recipes folder with Alice and Bob that originated in Bob's home directory. What does my local snapshot of the file system look like, and how am I interacting with it?
Yeah, I mean, when we first implemented it, you locally didn't store any files. All the blocks that used to make that soup directory were loaded from the network as you needed them and written back as you wrote them, and nothing hit your local disk at all. And that was kind of V1 of Keybase. Since then, we made a bunch of different changes to improve performance. And so one change that we made is that we have what's called a file system journal, so that you can, if you're doing a whole bunch of operations, like let's say you're untarring or uncompressing a compressed zip file, that's a classic example where like one click of the mouse can cause 100,000 small file system operations. So now our most recent client will just kind of write them to local disk, buffer them up, and send them all in batches, so that each of those 200,000 operations isn't a round trip to the server. So that's one thing we've changed recently for performance. And the other thing is that if we see you're accessing the same files over and over again, we'll just prefetch on your local client those blocks that correspond to the files that you access the most. And those are just optional improvements that are not there for correctness, but just there for performance. And obviously we're still trying to find the right trade-off between performance on the one hand and not hogging too much storage on the other. And there are a bunch of sliders you can slide in between there, but that's more or less our model. So it's a totally different model from the Dropbox model. It's probably closest to the Dropbox Infinite model, which they released last year for their business customers, which is a little bit more on demand. You don't have to selectively sync ahead of time this whole part of your shared files. You just kind of go and access the files, and they magically appear. So that's like the easiest kind of comparison I can draw to what's currently out there in the market.
Sorry, but you are storing the files on Keybase's servers.
Yes, we're storing everything, and we use Amazon Web Services. So everything is stored as encrypted, signed blocks. And blocks can be anywhere between, 100, let's say 1,000 bytes for, small files or small directories up to I think the maximum block size is 8 gigabytes, 8 megabytes or 8 gigabytes. I think it might be 8 gigabytes. And then, from there we could make much bigger files by putting a bunch of these blocks together and making bigger files. Actually, I'm wrong. The maximum block size is 512K. So that means if you have let's say a video that's, I'm not going to do the math right, but let's say it's a terabyte long, that means you'd split this file up into 512K blocks and kind of store each one of those individually on the Keybase servers. And then, the person you're sharing with would kind of download all those blocks and stitch them back together and present a file to your application so the application can watch the video.
Okay. And so on my local device, I've got, is it basically like a directory structure? I don't have the actual files, but I've got like a directory structure. Mm-hmm. And every time I open a file that's on that directory structure that I have access to, like the recipe, it's going to check and make sure that my the private key I have locally can be used in concert with one of the public keys that I signed up for this file with, because in that example you gave with Alice and Bob, where they've got 9 keys between them, and maybe I've got 3 keys myself, and that's 12 keys. So there's 12 different devices that can access that file, and as long as I've got one of those keys that gives me access to that file, I can retrieve it from the server.
Yeah, exactly. So you can retrieve it from the server A, and B, you can decrypt it. And the server doesn't know if you can decrypt it. It just hopes you can, because it certainly can't. Yes, and then once the blocks are decrypted, indicate to the software running on your machine how to stitch the blocks back together to make a file system, to make a directory tree, to make it look to your local operating system like you're dealing with a local file system. But that's an illusion. It's just something that's just presented at the very last minute to the applications to make it look like regular files. But really, these are encrypted, synced, signed files without the applications having to know it.
So what if I try to access Sally's recipe for green bean casserole and I don't have permission to that, but I'm accessing it in a place where it actually exists on the Keybase's global remote file system? Am I going to get some blob of blocks, and then I'm going to fail to be able to encrypt it?
Yeah, actually, we're doing a little bit of belt and suspenders here. We're not even letting you download that block to begin with. You'd have to prove first to our servers that you could access and that you were one of the people listed in the access list for that file, and you'd do that through just kind of a standard authentication mechanism. And then once you did, you'd be able to download the block and then decrypt it. So in the case you mentioned, you'd fail even to download the encrypted block to begin with, because why should we let you even do that? It seems like a safe thing to do. But if someone broke into our servers and published all of the contents of our S3 buckets to the world, then we'd obviously lose that first. We'd lose the suspenders, but we'd still have the belt, which is that obviously you need the private key to decrypt to actually look at Sally's recipe.
So what goes on in that communication between the client and the server there, where I've got to be able to authenticate somehow to be able to even prove that I can get the right blob of stuff?
Well, this we have a very convenient answer for. Authentication is done with your signing keys. So the server presents you a challenge and say, "Hey Jeff, please sign the statement for me," and then you use your secret key you have to just sign that statement and send it back. And the server knows what are the public keys that ought to represent you, and therefore it can say, "Yep, that's Jeff. He can he's allowed to access this data." So it's not too different from authentication you would do with your bank, but it's better because it's using public key. It's probably most similar to like SSH authentication, where if you SSH to another machine, you're probably not typing your password. You're just using this automated experience where you're using your local secret key to sign a challenge to prove you are who you say you are to the server.
When you build a new file system these days, how much can you take off the shelf?
It's a good question. We actually wound up basically not taking much off the shelf. We take our crypto components off the shelf for sure. So this is a decision we made early on that's just been so far and away the right decision. We used the SALT or NaCl library written by Dan Bernstein to do all of our crypto. And it's just, every week you'll see another vulnerability in other libraries. Like, GPG has had all of these timing attacks that people come out with. And today I believe there's a problem with hardware generated PGP keys and some weird implementations of PGP devices. And we've just had not even close to a problem with this library, and we've been just so grateful for it. And I mean, he's made so many correct decisions, and all these vulnerabilities keep reinforcing that in our minds that this is just great engineering. So that we took off the shelf. We are very grateful for Go and for the incredible libraries that they have, because I come from a background where we used to write everything in C++, and the issue I always had with C++ is it was so hard to assemble a group of libraries that worked well together, because everyone had a slightly different model of threading or a different memory protection and kind of garbage collection model. And the nice thing about Go is everything in the ecosystem works together so seamlessly. So all that stuff we've taken directly off the shelf. But when it comes to a cryptographic file system that's distributed and that works with our identity model, we really couldn't use anything aside from those components I just spoke about. So we had to write a lot of it ourselves.
Mm-hmm. And tell me something that was really hard about building the distributed cryptographic file system that is Keybase file system.
Yeah, I mean, it's an ongoing challenge. And one of the challenges of a file system that's accessed in this way, where it's like this on-the-fly access, is that the operating system is giving you pretty stringent requirements. On OS X, for instance, we have to answer a system call in 19 seconds. And if we don't, there'll be a message sent back to the client that says like, oh, your file system is not available. And obviously, if you're plugged into a great connection, that should not be a problem. But if you're on a laptop and your Wi-Fi cuts out, it's a little bit more of a problem, because you could easily have 30 seconds of disconnectivity that is just normal, but we have to find a way to mask that as far as the user is concerned. So that's been one of our biggest challenges, just dealing with that 19-second timeout. And I believe Linux has like a 60-second timeout, so it gives a little bit more time. But we've had to come up with a whole bunch of strategies under the covers to if there is a network condition that's not great, to kind of mask that and let the application keep working. So that's definitely been one of the biggest challenges.
You touched on this earlier, that you integrate with the blockchain, the Bitcoin blockchain, to ensure integrity of the Keybase file system over time.
Yes.
Come back to that.
Sure. So everything in Keybase, from the file system to the depictions of people's identities, everything is stored in a series of what are called append-only data structures. And so what that means is that we wanted to avoid the case in which an evil Keybase could drop things off the end of people's identity chains. So here's a good example. I leave my phone in a cab. The cab zooms away. I go to my computer and I say, please revoke my phone. And Keybase gets that request, but just doesn't propagate it to the rest of the world. And it just kind of hides that and it pretends I never said it. And so now that person who gets my phone, who finds it in the cab, can then access all of the Keybase services as if they were me, even though I tried to revoke the device. So that's something that needs a good solution. And the solution, more or less, is what we call these append-only data structures, to make sure that an evil Keybase is never in a position where it's able to roll back the state of the world to a previous state. That once it publishes a state, it can only make changes and modifications to that state. It can't pretend that something that happened, that it said happened, didn't happen. So we built everything in Keybase with an append-only data structure. And that still leaves one attack open. And one attack is that if I'm showing a version of Keybase to you, and I'm showing a different version of Keybase to your friend, I can get away with that as long as I never try to merge the two versions together. So it's like basically I could fork the state of Keybase. I could be appending onto fork A and appending onto fork B, and this is like a super evil Keybase. It could just make sure that both sides of the fork never know about each other, and then it can get away with that. So there's one additional precaution we take, which is that Keybase has to say this is the right version of Keybase in the Merkle in the Bitcoin blockchain, and there's only one of those, and so therefore that kind of fends off this last attack, this forking attack, because Keybase would be forced to put either fork A or fork B into the Bitcoin blockchain. It can't do both, and so therefore anyone who has access to the Bitcoin blockchain can know they're on the right fork. So that's what we think. Everyone talks about Bitcoin for solving a million different problems. This is, in our view, the most important problem it can solve, and everything else we can do off the Bitcoin blockchain and get all the security guarantees that Bitcoin allows.
What an elegant solution. I know we're up against time. You have had some pretty cool product releases recently with
Yes.
Keybase Teams and Keybase Git. So Keybase Teams is described as like Slack for the whole world, or a team Dropbox where the server can't leak your files or be hacked. And Keybase Git is Git on top of Keybase. Could you quickly talk through these products and how they, I guess, also how they represent the big vision of Keybase?
Yes. So our big vision is that we want people to use Keybase for applications today. I think our biggest vision for Keybase is we want to build this graph of cryptographic identities where you know who my friends are, and these are not just Facebook saying it's this link, but this is like the real cryptographic link that nobody could have possibly faked. And we want people to know what all my devices are. So that's like the ultimate overarching goal of Keybase. But before we get there, we really want people to use this product today for problems that they have. And I think Teams is something that took us forever to build because it was actually quite complicated. And we got to Teams because the original version of Keybase wasn't sufficient for a lot of people's needs. I mean, it's easy to say like Bob, Alice, and Jeff are this small group of people, and they're never going to change, and they're never going to add Sally. and that's what our original version of Keybase was good for, but that doesn't work at all for people's companies where obviously employees come and go. And it's nice to have a name for something. And so that's where the idea of a team comes in. Now, we talked several times about how a person's identity is this kind of sliding window of device changes, and it's only after you play them all back in the right order that you get to the right version of what the person is at the present. So a team is the same thing, just one layer up. And so a team is a combination of people where you and I start a team and we add Sally, and then Sally adds Bob, and then I decide to delete Bob, and so on. And so there's this very kind of parallel structure in the team where the composition of the team is changing over time, but it's always cryptographically verifiable that it's the right team of people. And you can imagine a server attack here where, let's say you and I are on the board of directors of a public company, and we're discussing some sort of upcoming big decision, and our nemesis is trying to get access to this data. One thing they could do if they co-opted Keybase is to insert a fake person into the team that just gets to, a fake director who's just getting access to all this information. And unless your system has some sort of protection against that attack, all the encryption in the world doesn't help you. And so what Keybase Teams does is it allows the users of the members of a team to audit and verify that the correct team members are in the team at the given time. And so that's why that's kind of a snapshot of why it was so challenging to build. But once we build Teams, we just unleashed it on all our existing products. So I mentioned before, it works with KBFS, it works with our chat product. And that integration was actually pretty easy. It was just kind of the building out of the Teams infrastructure that was the challenging part. So that's something that we think is quite transformational. Anyone who's using something like Slack inside their organization, I mean, if it were me, I'd feel a little bit worried that if Slack is ever compromised, I'd lose a lot of very important data. And so we want Keybase Teams plus our chat feature to be like a good drop-in Slack replacement, with the important added distinction that everything is cryptographically verified and end-to-end encrypted, which is, we think, quite a unique feature. The other thing that you mentioned, Git. So Git is kind of a different interface into a file system, and there's a couple more steps. If you were to write a soup recipe and sync it to your friends on Git, you'd have to type git commit, and then you have to type git push, or you'd maybe use some sort of graphical user interface to do that. And it's a couple more steps. However, it's what people are probably doing now anyway when they start to collaborate on files, especially source code that has like a lot of different authors, where you also want to have a very clear way to review history and to see when a bug was introduced or to resolve conflicts. So we think that, I don't have to sell Git to your audience. I'm sure everyone loves it, but we just wanted to have a very easy way to use Keybase file system for Git. And that's all that Git was. It was actually a pretty easy feature for us to build because so much of the foundation was already laid in the previous features that we talked about. And of course, it works with teams and it works with personal repositories too. So, I, for one, I'm a tremendous user of this feature. We run a web service. We have a lot of API keys. We have a lot of configuration data. We do not want to push that data to GitHub because though GitHub is great for things like code reviews and file browsing, it is not a place I'd ever feel comfortable storing my secrets. And so we use Keybase almost exclusively for anything that has secret data in it. So that's either chats or configuration files or, internal kind of management documents for managing our finances or employee offers and stuff like that. Those are things that we feel much better if we keep it secret and manage on Git on top of KBFS. Yeah, those are our two most recent features, and we're super excited about them because we feel like they're good drop-in replacements for what people are doing now, and they have these amazing security properties that are quite challenging to provide.
Max Krohn, thanks so much for coming on Software Engineering Daily. It's a really ambitious project that you're working on with Keybase, and I love reporting on it.
Thank you, Jeff, and thanks for the thoughtful questions and for giving me time to talk about this product. Thanks so much.
Absolutely. Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!